Hello and welcome back. This video covers the AMDM lesson, Activity 3, Time Value of Money. Here we have a table that represents the number of years in the left column and the balance in the right column. So after year 0, we have a balance of $2,600. After 5 years, we have a balance of $3,201.50. All the way down to 30 years, and the balance would be $9,062.70. Right? In question 1, it asks us to create a scatter plot. Well, that is already done for us, so the first point that you see is the point 0, 2600. That would be this point here. And then the next point is 5, 3201.50, which is this point. So the scatter plot here is already done. And then the question at the bottom, what type of function would best model the data? Explain your reasoning. And the answer is exponential. Okay, this is exponential because the points are increasing at an increasing rate. We can tell that the data is increasing at an increasing rate by looking at the differences between each number. To go from the first value to the second value, we add 502. To go from the second to the third, you're adding 740. To go from the third to the fourth, you're adding 911. So the amount that you're adding is increasing, and therefore that supports the fact that the data is increasing at an increasing rate, and therefore it is exponential. All right, question 2 says calculate the regression equation for the given data. Now let me pause here. You will be able to calculate this regression line, but I'm not going to show you that during this video. I will show you that at a later date, but it requires the technology on the TI-84 calculators. So here the equation is already given to us, and that is this equation, 2600 times 1.0425 raised to the power of x. Okay, now let's answer question number 3. According to the model, that is this equation here, what is the interest rate for the savings account? Here's how you calculate the interest rate. You take the multiplier, the common ratio, which is 1.0425, subtract 1 from it. So 1.0425 minus 1 would give you 0.0425, which is the portion that comes after the decimal. You just move the decimal point to the right 2 places, and you have 4.25%. So that, ladies and gentlemen, is the rate of increase. So our interest rate, or rate of increase, is this 4.25. And again, you take the decimal minus the 1, that gives you 1.0425. Move the decimal point to the right 2 places, and you have 4.25%. Question 4, use the model. How much will be in the account in 50 years? All right, well, the equation is 2600. That's the amount we started with. The common ratio is 1.0425, and it's raised to the power of x, where x is the number of years. And then all we have to do is plug in 50 for x. So we get 2600 times 1.0425 raised to the power of 50. And our answer is $20,834.19. All right, and then question 5, use the regression equation from the previous problems to write a general formula for future value of an investment compounded annually. Use the following variables. FV stands for the future value. That would be like Y. T is the time in years. That would be like the X here. I is the interest rate. That would be the point, the decimal part of this common ratio. And then PV is the principal, or the present value. So our equation would be this. Future value, which is Y, equals the present value, that's like the 2600, parentheses multiplied by 1 plus I, that would be the 1.0425. The I is the interest As a decimal, that would be the 0.0425 part. And that's added to 1. And then it's raised to the power of t, where t is like x. That's the number of years. Okay, number 6. All the investments so far have compounded and paid interest annually. However, some investments compute interest in compounding periods that are quarterly or monthly. If the annual interest rate is divided evenly, how would the interest rate be calculated for each compounding period? Well, there are 4 quarters in a year, so if it's compounded quarterly, then you would divide the interest by 4. And then what about monthly? Well, there are 12 months in a year, and so monthly you would divide the interest by 12. Okay, number 7, write a general formula for future value that takes into account any compounding period. Use the variables from question 5 in addition to n for the number of compound periods in each year. All right, so the variables from question 5 were FV, that's future value, equals PV, present value, times 1 plus the interest rate. And this time we have to divide the interest rate by the number of compounding periods, so the interest rate would be divided by n. And then, because you have n compounding periods, the t in the previous formula needs to be multiplied by n. So here is your compounding formula where you are compounding n periods in a year. Okay, number 8. Suppose you invest $2,600 in a savings account with a 4.25% annual interest rate that compounds interest quarterly. Use the formula you wrote in question 7 to determine the balance in the account after 5 years. So we have future value equals the amount you started with, $2,600, that's your present value, times the quantity 1 plus I, your interest rate, as a decimal, 0.0425, divided by n, where n is the number of compounding periods, and since we're doing it quarterly, that's 4 quarters in the year. So that's 4 there. And then raised to the power of n times t. All right, n is 4, and then t is the number of years, which is 5. Now you'll multiply 4 times 5, that'll be 20. So your exponent is going to be 20. When you put this in the calculator, that's the 2,600 times 1 plus this fraction, all raised to the power of 20. You're going to get this answer here, 3211.99. And in question 9, how much would the same savings account be worth in 50 years if the interest is compounded quarterly? All right, so we went from 5 years to 50 years. All right, so what that would be is just changing the time period to 50. So we'd use the exact same question. Future value is 2,600 times 1 plus 0.0425 over 4 raised to the power of 4 times 50. Now 4 times 50 is 200. And then you'll just put that in the calculator. You'll put 200 in as your exponent. And you will get 21,526.86. Okay, and then question 10 is a reflection. Is there a difference between the account balance in question 8 and the account balance from problem described in the table? If so, is the difference large or small? Okay, well the answer is that there's really not much difference. If we go back and look at the table, after 5 years, the table says the value would be 3201.50. That's compounding annually. If we compound 4 times a year, it's 3211. So that's only, a little more than $10 more. So there's not much difference, and that's basically because it's only over a short period of time, 5 years. And then question 11, is there a difference between the account balance in question 9 and the account balance in question 4? If so, is the difference large or small? Okay. Well, in question 9, the balance was $21,526. In question 4, the balance was $20,800. That's a significant difference to me. That's like almost $700 difference there. So that's significant, and that's because it's over a longer period of time. It's over a 50-year period as opposed to a shorter period of time. All right, that's it, folks, for this lesson.